for it.
Howdy, I'm Reed Smetter. I'm a second semester master's student at UTRGV in the ACE program, Agricultural, Environmental, and Sustainability Sciences. And my poster is about pesticides and poverty, how pesticides impact rural communities on the U.S.-Mexico border. So just to get into an introduction, just in case whoever's watching this isn't super familiar with pesticides, they're used to help reduce the populations of weeds, insects, and pathogens, what we call pest species, in agricultural and in urban settings. So they operate on different levels. Different pesticides are used to target different things. They could be fungicides, which target fungus, herbicides, which target plants, nematicides. You get the vibe. So we wanted to see, Dr. Chaudhry and I, wanted to see whether there was any sort of correlation between rurality, how rural a county is, how much pesticides they see, and what the poverty levels are like in those areas. Of course, this ended up with some future research questions. Of course, you get into something and you start having more questions than you have answers that you gained. Totally typical for science. There's a personal impetus for this as well. I lived in Bayview for about 7 years. Bayview is a very small town. There's a very small population, less than 1,000 people when I lived there. I think the population size said 383. However, there are a lot of citrus groves there. Across my parents' house and property, there was the next property over, and then there was a commercial citrus grove right next door. So I would also see a lot of crop dusters, planes that are spraying pesticides from up in the air whenever I would go to my friends' places or leaving Bayview to go to school. So I was kind of curious, okay, where's this intersection of these different social factors and pesticide use? So using RStudio and utilizing some data sets from the USGS Pesticide National Synthesis Project, which thankfully is still up. They have data from 1995 all the way up until 2019. Miraculously, those data sets are still available by the time that I got to it. About 3 weeks ago, when Dr. Chaudhry and I landed on this topic as part of my thesis, we made this map, which is just the overall weight of pesticides applied by county in the United States. I'm reading off of the slides here, of course. These are normalized for area. So some of these places, like these counties here in Southern California, lots of agricultural production, lots of pesticide use, but they're also huge. They are massive. Some of these counties are bigger than some of these northeastern states, right? So we had to normalize for the actual area over which this pesticide is being applied. There are some key places. You might be thinking, okay, we use pesticides wherever we're growing crops. You'll be using pesticides wherever you grow crops. That is most of the story, but part of it is that you want to spray pesticides in places you're growing crops that are valuable enough to spray pesticides. Because if you're going to end up going negative on your budget when you're spraying pesticides, because pesticides are expensive, as are most things in the agricultural field, you're not going to want to use much pesticides. So some of these places here, Central and Southern California, we've got apples, cherries, and tomatoes that are grown a lot here. And up here in southeastern Washington, northeastern Oregon, those are where cherries and wheat and tomatoes are grown. So these are kind of higher value crops as compared to things that we grow in the valley. Up until recently, we grew sugarcane down here, which is why there's not a ton of pesticide application relative to places like the Northwest or California. So we took these data sets, we highlighted the counties here. We plotted poverty percentage and total pesticide application by county. These red dots here represent border counties. These are counties that are actually on the U.S.-Mexico border, because that was the initial focus of our question. And you might be wondering, why does it kind of centralize around this 10 to 20% poverty range as opposed to over here in 50%? There's actually a negative linear correlation, so the more impoverished the county is, the less overall pesticides the trend shows. This can be explained by a few different things. Like I mentioned earlier, different crops are worth different amounts of money. So these really impoverished counties, where they're 40 or 50% impoverished, they might be growing things that are worth lower amounts of money, and they also might just not be growing things there in general. So another thing that we plotted over here, total pesticide application by county, again on the y-axis. X-axis, the index of relative rurality. This is basically saying what percentage of each county could be considered rural. It's not like a typical index where it goes from 0 to 1. It actually, the highest value that you can see here is about 0.78, 0.79. So the most rural county in the United States is about 80% rural. But as you can see, it is a slightly right-shifted normal distribution. It is slightly centered and slightly pushed towards over 0.5 virality, so it kind of suggests that the more rural you get, the more pesticides they're being applied, which makes sense if we go back to you spray pesticides where you're growing crops. And just one last thing, I know I've taken a bunch of time. Some of the questions that were posed by this future research is the question of, okay, we're spraying pesticides. There are many different pesticides. There are over 400 pesticides represented in the USGS dataset. Some pesticides are more harmful to human and environmental health than others. Some of them might be super toxic, some of them less so. Of course, that's relative. I still don't want like glyphosate or 2,4-D being sprayed on me, but there are some that are worse, some that are less harmful. So that's another thing that we're going to focus on in our future research. Again, this was about 3 weeks ago that we settled on this topic, so got this done pretty quick. And of course, as with all things science, we get some answers and we get more questions. That's everything.
All right.